The digestion of lipids begins, to a small extent, in your mouth, with the secretion of salivary lipase from saliva glands located under your tongue. This enzyme primarily breaks down triglycerides containing short-chain fatty acids into free fatty acids and a monoglyceride. To a much greater extent, lipid digestion takes place in the small intestine with the aid of lipase that is produced by cells in the pancreas. This lipase enters the small intestine by way of ducts or channels that carry lipase as well as other digestive enzymes to the small intestine. There, lipase breaks down triglycerides to free fatty acids and monoglycerides. Lipid digestion is greatly aided by bile, a substance that comes from the liver. Bile contains phospholipids and bile salts that are necessary for fat absorption and digestion. The phospholipids in bile surround small amounts of fat, forming droplets, thereby suspending the fat droplets in a water medium. This is a process called emulsification that significantly promotes the interaction between triglycerides and lipase. With regard to phospholipid digestion, certain enzymes from the pancreas and cells in the wall of the small intestine digest phospholipids. The eventual products are glycerol, fatty acids, and remaining parts. With regard to cholesterol digestion, any cholesterol with a fatty acid attached is broken down to free cholesterol and fatty acids by certain enzymes released from the pancreas. Free fatty acids, monoglycerides, and cholesterol await absorption through the small intestinal lumen in droplets surrounded by bile. These droplets are called micelles. Although the name contains the word cell, micelles are not living cells. They are simply a conglomeration of digested lipid products encircled by bile that are awaiting absorption. Free fatty acids and monoglycerides are absorbed into the small intestinal epithelial cells via diffusion. Small and medium chain fatty acids are generally absorbed out of the epithelial cells into the capillary network within the intestinal villi, where they will be transported in the blood to the liver. Long-chain fatty acids reform triglycerides within the epithelial cells. The triglyceride, along with some cholesterol, protein, and phospholipids, are encapsulated into a large structure called a chylomicron. Chylomicrons exit the epithelial cells by exocytosis and enter the lacteal located in the middle of each villus. The lacteals are connected to lymphatic vessels that enter the venous circulation en route to the heart. Chylomicrons are the largest and least dense of a family of transport vehicles for lipids called lipoproteins. As the name implies, lipoproteins contain both lipids, i.e. triglycerides, cholesterol, and phospholipids, as well as proteins. Lipoproteins serve as vehicles for the transport of lipids from the small intestine and liver to the body tissues, where they are taken up by cells and used as energy or stored as fat.
Lipoproteins are classified into 5 categories based on their densities: chylomicrons, very low density lipoproteins, intermediate density lipoproteins, low density lipoproteins, and high density lipoproteins.
Lipids are less dense than proteins. Therefore, lipoproteins that contain a large proportion of lipids in comparison to protein are less dense than those depleted of lipids. Once a chylomicron enters the bloodstream, The triglycerides in its core are broken down into fatty acids and glycerol by an enzyme called lipoprotein lipase that is attached to the inside walls of the blood vessels. As soon as fatty acids are released to the bloodstream, cells in the vicinity absorb them, while much of the glycerol circulates back to the liver. Muscle cells can immediately use the absorbed fatty acids for fuel. Adipose tissue, on the other hand, tend to reform the fatty acids into triglycerides for storage. After triglycerides have been removed, a chylomicron remnant remains. Chylomicron remnants are removed from the circulation by the liver, and their components are recirculated to make very low density lipoproteins, or VLDLs. These particles are composed of cholesterol and triglycerides surrounded by a water-soluble shell. VLDLs are rich in triglyceride and thus very low density. Once in the bloodstream, lipoprotein lipase on the inner surface of the blood vessels breaks down the triglyceride in the VLDL into fatty acids and glycerol. Fatty acids and glycerol are released into the bloodstream and taken up by the body's cells. As VLDLs lose triglyceride, they become denser and composed of a larger proportion of cholesterol. These lipoproteins are referred to as LDL, or low-density lipoproteins. The primary function of LDL is to transport cholesterol to tissues. LDL particles are taken up from the bloodstream by specific receptors on cells, especially liver cells, and are then broken down. The cholesterol and protein components of the LDL provide some of the building blocks necessary for cell growth and development, such as synthesis of cell membranes and hormones. The final lipoprotein fraction is called HDL, or high-density lipoprotein. HDLs are formed in the liver and have the highest proportion of protein, and thereby have the greatest density. HDLs roam the bloodstream, picking up cholesterol from dying cells and other sources. HDL donates the cholesterol primarily to other lipoproteins for transport back to the liver to be excreted. Your proportion of these various lipoprotein fractions have implications to your risk of serious diseases such as coronary heart disease. In general, low risk of coronary heart disease is associated with low total cholesterol, low LDL cholesterol levels, and high HDL cholesterol levels. In contrast, higher risk of coronary heart disease is associated with higher levels of total cholesterol, higher HDL cholesterol levels, and lower HDL cholesterol levels. It also appears that consumption of saturated fat and trans fats leads to an increase in free cholesterol in the liver. This increase in cholesterol diminishes cholesterol removal from the bloodstream, leading to an increase in the LDL cholesterol fraction.